Hi, I'm Nathan Spencer from Revo Group. Ausgrid got us involved in this job after a few discussions around what design methods were possible, just to see if they could make their foundations a bit more efficient and get a bit more confidence in their foundation design, whilst also being compliant with AS 7000.
Ausgrid had traditionally been installing their poles at 10% plus 0.6 or 1 metre depending on where you were in the organisation. We also did this irrespective of the tip load capacity of the pole or the conditions of the ground that the pole was being installed in. There was an inconsistent approach. After doing some research, it was evident to me that there wasn't much engineering justification to be doing so. Revo Group was an obvious choice for a number of reasons. Revo Group previously provided contracting services to Ausgrid in the form of foundation design, pole tests, but also provided advice for implementing templates within our line design software. Revo provided us with input into our design parameters for detailing wind code, interpretation and component strength reduction factors for implementation in Ausgrid policy. It was because of the success of these previous services that we had Revo come in and guide us through a few scenarios and different foundation design methods with details of how best to manage our requirements and provide us with an optimised solution.
To do that, we looked at a whole range of different lateral foundation design options, different theories that are available. We ended up choosing the PY method as being the most appropriate. The trick then was to actually build it into a format that was easy to use, could be used by a range of different people within the organisation, and to link the soil classifications between what you get from a geotech engineer and what the guys can report back from in the field without being geotech engineers.
It's been really helpful in planning jobs, whether it be in design of a project or sort of ad hoc in emergency situations when we're unsure of the ground condition or the size of the pole that's required.
That was part of the problems before, in that the guys on the front line didn't have exposure to what ground conditions they were expecting, and they didn't necessarily understand why they're going in so deep. But now they've got a report in their hand, they've got direct link between that report and what soil to expect. There also is another good aspect about the inclusion of the WebPEC report in the front line, is that the guys have more flexibility in terms of coming back to the engineer to ask questions if things aren't as they expected. So in this particular scenario, the conditions were verified as being sand, medium coarse sand, so we were happy to proceed with that design.
Gone are the days of the outdated method, I guess, of the 10% of the length plus 1 metre. That's not going to work for all ground conditions. Sometimes there's rock, and today it's a sandy sort of ground setup. The
user manual for the software can actually be used by the people that are designing using the software and also the guys in the field. So we've actually linked up like a field guide to soil types, so that when they are looking at the report from WebPEC, they can align what they're seeing in the report with what's in the ground, and if there's something significantly different, they can report back and the design can be changed basically on the spot. And that just closes the loop for the foundation design part of the project. In the end, it was a really interesting project. It was really good working with the guys at Ausgrid. It was a nice collaborative effort.
Revo Group were faultless in their response and quality of service that they provided Ausgrid. The whole process was collaborative, with stakeholders in the game being engineering, design, policy, standards, project management and the ICT team.
The end result, I think, speaks for itself. It's being used. No one's really coming back with questions all that often. When they do, it's very easy, simple answers.
More recently, with the use of the WebPEC program, the relationship between the field staff and the designers, you know, there's a lot more confidence when we've got the figures there, rather than coming up with a number or an old school method. We know the ground condition now with the WebPEC, and we know the exact depth that's required.
We were also able to roll this out to our ASP designers with a huge level of confidence, and the feedback that we've been getting so far is very positive.